Don't forget to subscribe and ring that bell.
Welcome back. We are going to continue these wonderful journey down the 2021 AP Calculus AB free response questions. We're done with questions 1 and questions 2. We are done with our calculator. We get absolutely no calculator. And the look of disgust on some of your faces, the terror that some of you must be going through right now. But you know what? Don't worry. The math is typically a lot easier when you don't get a calculator. It should be. The algebra is easier. You just got to worry about the setup of the problem. Let's start free response question number 3. Okay, they give us some sort of a graph here, and this is fine. Problem 3 reads, a company designs spinning toys using the family of functions y equals cx times the square root of 4 minus x squared, where c is a positive constant. That seems pretty important, okay? The c is a positive constant. The figure above shows the region in the first quadrant bounded by the x-axis and the graph of y equals cx square root of 4 minus x squared for some value of c. Each spinning toy is in the shape of the solid generated when such a region is revolved about the x-axis. Both x and y are measured in inches. Not sure if that will come into play yet, but let's see. 3a says, find the area of the region in the first quadrant bounded by the x-axis. All right, let's go. By the x-axis, boom, and the graph y equals cx times the square root of 4 minus x squared. That's this thing right here. So we're basically finding the area under this curve. We're finding this area. And if you don't know by now, shame on you that the area under the curve is the integral. All right? It is the integral of our equation. But they give us one more bit of information, and that is right here. They want us to find the area under the graph for a c value of 6. Okay, so if I'm looking at my equation right here, all right, this c value, we're going to put a 6 in right there for that c. So that's 6x square root of 4 minus x squared dx. Now keep in mind, this is not a calculator problem. We can't just throw this in the calculator. And we've got to kind of show our steps. It's really important to get full credit. So this is all I'm doing. 2 things that kind of stick out to me. First off, what are my bounds? I'm going to look at my graph. I know it starts where x is 0 right here, but what's this value? What is that? Okay, so down to my integral, my lower bound is 0, but I don't know this upper bound yet. Well, I need to see where my function is equal to 0. I got to find the 0 value here. So on the side, okay, on the side, I know my c is 6x square root of 4 minus x squared. Where does that equal 0? All right. Well, really, it's kind of like I've got 2, like I've almost got factored. I'm just going to T-bone and solve for both of these, right? We know 1, 6x equals 0. And if I divide both sides by 6, x equals 0. That's one of my zeros. That's the lower bound here. We know that one. Okay. So now I've got to set my other factor equal to 0. So the square root of 4 minus x squared equals 0. Well, if I want, I could just square both sides. Get rid of the square root. That's still 4 minus x squared equals 0. Okay. And I mean, if you don't know this by now, I mean, it should be obvious the answer is 2, but I mean, if you want to finish this off, let's go ahead and finish this off. We're just going to add x squared to both sides. 4 equals x squared. And I tell you what, the number of, oh, excuse me there with this little drop, the number of people that just tell me x is 2, when you take the square root, it's positive and negative 2. The only thing I'm looking at here, though, is I'm only concerned about the first quadrant. Okay? Now, if this is positive 2, I mean, at negative 2 here, we have another 0. But I don't care about this part. So I am going to use only positive 2. Okay? But keep in mind, when you're solving things, when you're undoing a square, it's plus and minus. But in our case here, we're only concerned about positive 2. So let me go back up. We have our two bounds, and now we can put a positive 2 on the upper bound of our integral. So I said I was concerned about two things. The first are the bounds. That's settled. Okay, next, I'm going to kind of simplify what I'm integrating here. All right? And let's start by saying, I'm going to take the 6, it's a constant, I'm just going to move this outside. So it's 6 times my integral. Okay, I've got x, and I'm going to make this square root into an exponent. I'm going to make this an exponent of 1/2. Okay, because anytime I deal with integrals and derivatives, it's always easier when we have exponents. So we have 4 minus x squared to the 1/2 dx, and I still have my bounds 0 to 2. All right? So I'm looking at this, and this is a clear-cut u sub. Okay, I'm going to u sub this right here. Let's go blue. I'm going to make u 4 minus x squared. So this is going to be u to the 1/2. All right? That means my derivative is going to be negative 2x dx. And if you'll notice in my integral, I only have an x and a dx. So here I only want to keep the x and the dx. I want to get rid of that negative 2. So I'm going to multiply both sides by a negative 1/2. This cancels, and now I get a negative 1/2. So in for my x dx, I'm going to put a negative 1/2 du. This will turn to a du. And my negative 1/2, that's a constant. I'm going to put that out here with a 6. Okay? And again, the x dx, the du comes out. Okay? So really, this is all I have now. But I need to change my bounds. Don't ever forget I need to change my bounds. Okay? My upper bound is 2. When I put a 2 in for the x, 4 minus 2 squared, which is 4, my new bound will be 0. Ooh, interesting. And my lower bound is currently at x equals 0. When I throw a 0 in for this x, 4 minus 0 is 4. Ooh, so my bounds, the larger values on the bottom, I don't like that. I'm going to flip my bounds, but what that means is I'm going to have to negate my integral. Okay, there's a rule. If I flip the bounds, I'm going to have to put a negative sign right out front here. So let's consolidate this a little bit more. Okay, my integral is now going to be 4 to 0, and I've got to negate whatever this is. Negative 1/2 times 6 is negative 3. And when I negate a negative, that turns into a big old fat positive. So I have a positive 3 out front now. Okay, and what do I have left? U to the 1/2 du. Well, that's easy. I just add 1 to my exponent. U to the 3/2. Okay, 1/2 plus 1 is 3/2. And I divide by that new exponent. You should know now. You are in calculus. You should know now that when I divide by a fraction, it's like multiplying by the reciprocal. Okay? I want this from 4 to 0. And oh, by the way, let's not forget, I still got to multiply it by my 3. Okay? So again, as I said earlier in the first slide here, the introduction to this, the algebra is easy. It's typically more algebra. It's more easy algebra. But we could do this. Okay, we could do this. I'm writing a lot bigger than I normally do, and maybe some of you guys are like, about time, Visca. I'm going to put a 4 in here. Okay, 2, thirds times 4 to the 3 halves minus, and I got to put a 0 in, 2 thirds times 0 to the 3 halves. This is nice. This goes bye-bye. I still got to multiply this times 3. All right? Still got to multiply that times 3, which this is really going to kind of be nice for us. All right? These 3's cancel. Okay, the square root of 4 is 2, and 2 cubed is 8. And I still got to multiply that times 2. The answer is 16. The area under the curve is 16. Now, this was a busy problem. Why? First of all, okay, I think it's clear-cut, the area under the curve there. We only had one. We had the lower bound. We didn't have the upper bound, too. We had to solve for that. Then we had to create our integral, which is using u sub, taking a constant of 6 out. All right? My du has a constant of -1/2 that's going to come in out front with the 6. I got to change my bounds and then do my algebra. So for part A, I mean, it wasn't difficult. It was just a lot. Okay? But we got it. We're done. And the answer is 16. Okay. So we are going to follow the theme of more deciphering before we can really get to the meat and potatoes of the algebra of the problem. 3b reads, it is known that for y equals cx, square root of 4 minus x squared, that the derivative dy dx is c times 4 minus 2x squared all over the square root of 4 minus x squared. For a particular toy spinning, the radius of the largest cross-section, circular slice, is 1.2 inches. What is the value of C for the spinning toy? Okay, a lot of, a lot of these problems, we've got to figure out what's happening before we can even do the math. And that's what we've got to do here. So, I'm going to be honest with you. Okay? I'm going to be honest with you. The largest, what is it? Where did I read it? It's known that for a particular spinning toy, the radius of the largest, here it is, cross-section. Okay, when this thing spins, okay, the largest cross-section is going to be wherever the maximum is in my graph. Okay, if I spin a little thing here, that's a smaller cross-section. The largest cross-section is going to be where my maximum is. Let's establish that first. Okay, that's going to happen where the max value is. I don't know, somewhere around there. Okay, so at this point, what do we know about mins and maxes? The derivative is 0. It can only happen where we have a critical point. My max happens where my derivative is equal to 0 or undefined, but we have no corners or cusps here. So it's where my derivative is equal to 0. They tell us that the radius of that cross-section, so if I have this big circle, that's fine, but the radius from here to here, okay, the radius is 1.2. That's the y value. The radius, 1.2. They're asking us for the c value. All right, let's get going. I'm going to take this fact right here. My derivative should be equal to 0. They give me, that is why they give me the derivative. The first thing I'm going to do is set this equal to 0. All right? So let's go down here, and let's take that information and run with it. Kids, I like to run. I don't. I hate to run. But, I'm in pretty decent shape, I think, for my age, but I'm not a big jogger or runner. Hiking up mountains, that's cool, but I'm not a big runner. All right, anyways, enough about me. Let's get back to calculus. If I take c times 4 minus 2x squared all over the square root of 4 minus x squared, when, let's make sure that square is underneath the radical, when is a fraction equal to 0? When the numerator is equal to 0. If my denominator is equal to 0, the fraction is undefined. Okay, we've already established that in the graph there are no corners or cusps. Nothing should be undefined. So right now, I just want to make my top equal to 0, my derivative. All right? So, in order for c times 4 minus 2x squared to equal 0, let's remember, they told us that c is just some number. That's not a variable. Okay, that is not a variable. If we look up here in the top right, it says c is a positive constant. So even if it's 6 or 2 or 3, whatever this number is right here, if I divide both sides by that number, 4 minus 2x squared equals 0 divided by any number we've already established right here. When the numerator is 0, it will still be 0. C does not even come into play. All right? So now let's add 2x squared to both sides. I'm going to extend this page. This goes bye-bye. So 4 equals 2x squared. We'll divide both sides by 2. So 2 equals x squared. Man, I could have sworn, if you watched part A with me, I reminded you that when I take the square root of both sides, it is just not the positive answer. It is a positive and a negative answer. Okay? It is a positive and a negative answer. But because we are only working in the first quadrant in our graph, okay, this might happen when x is the positive square root of 2. Because when x is negative square root of 2, it's going to be somewhere on the left side. And we don't want this. We only want the first quadrant. So there you go. So I have a derivative equal to 0, or a critical point, or a horizontal tangent right here, where x is the square root of 2. And they give us the y value, 1.2. The question below is asking us, what is the c value? That means the c value, okay, the c value here. I got the x there. Let's the c value right there. So guess what? I have an x, it's radical 2. I could just put that in here and here. I have a y. Let's put that in here, and let's solve for c. All right? There we go. Y equals c times x times the square root of 4 minus x squared. At the point, radical 2 for x, and y is 1.2. All right? So let's just plug those in. Y is 1.2 equals, I'm solving for c. X is the square root of 2 times the square root of 4 minus x, square root of 2, squared. All right, let's just run with it. Let's just do some algebra, kids. Don't be scared. So I've got radical 2 times c. For the square root of 2 squared means the square root and square cancel. That's just 4 minus 2, which is 2 underneath the square root, equals 1.2. All right. Well, if I multiply square root of 2 times the square root of 2, that's the square root of 4, which is 2. Now I'm just going to divide by 2. My c value equals 1.2 over 2. Half of 1.2 is 0.6. Yada, yada, yada. Done. 3c. This is the last part. There's no a, b, c, and d. For number 3, there's just an a, b, and a c. All right? 3c states, for another spinning toy, the volume is 2 pi cubic inches. That seems pretty important. 2 pi cubic inches. That's the volume. It's 2 pi. What is the value of c for the spinning toy? Oh my God. Spinning. At some point, you knew, okay, we were going to have to find the area, okay, or the volume. in order to find volume, you always got to integrate the area. Or in this case, okay, as we rotate around the x-axis, okay, we create a circle. Wow, that was weird what just happened there. We create a circle. All right, and the area of a circle is pi r squared. Okay, it is pi r squared. The pi is a constant. I'm going to put this on the outside. The integral is my radius squared. We'll just call that dr. That's what my volume is going to be. All right, the radius, okay, depending on where you are, this circle, the radius comes to the line. This circle, the radius comes to the line. So the radius is going to be whatever point falls on my graph. So the radius is the graph. Okay, the radius is going to be c x times the square root of 4 minus x squared. That's my y value, right? The radius here is what the y value is. The radius here is what the y value is. The radius here is whatever the y value is. And what's y? My equation. Okay? So I'm going to set this up. I'm going to take, can I move this? Oh, look at me go like a winner. I'm going to say that it is pi times the integral of my radius, which is c x square root of 4 minus x squared dx, okay? That equals my volume. But they give me a volume. 2 pi. Because I need to solve for c. I'm going to have to solve for this c here. Now, I tell you what, just like in 3a, when we made c a 6, didn't we just pull that right out? So I'm going to do the same thing for my c. And in fact, we have done the integration work right here already. All right? I mean, we're going to end up integrating this right here, which we already did. Okay, so I'm just going to pop here. Pop here. I'm going to come down here. And let's do this. Okay, let's do this. The c is a constant, so we're going to pull that out. So 2 pi is going to equal c times pi times the integration. And notice we don't have bounds yet. Okay, the bounds are still the same. This graph is not changed. It's going to be x times the square. Well, we'll change this square root to a 1/2. 4 minus x squared to the 1/2 dx. All right? Now, the bounds, they haven't changed. Again, in part A, we figured out that the bounds here, we already did this work. Goes from 0 to 2. So that's what we're going to do. From 0 to 2. Now, all right, we're just going to move forward here. We're going to move forward here. Are you ready? And as we move forward, I'm noticing, and this is a common mistake when we go fast, especially if we're going back and forth, my radius needs to be squared. So I can't just pull out this c. Let me back this up. I'm going to undo a lot of stuff here. Keep on going. Nope. That. Right there. This is my radius. And my radius needs to be squared, doesn't it? So that's why I put the parentheses here. That's the radius. I need to square it. This thing is the radius. I need to square it. That's going to change just a little bit. So if I square everything in here, this exponent's got to apply to the square root, which it'll cancel, to the x, and also to the c. So I now have 2 pi equals pi, the integral from 0 to 2. Let's not forget that. It's c squared times x squared, and the square and square root cancel. So times 4 minus x squared dx. This will make our integral a million times easier. I was looking at that like, this shouldn't be that hard, but it is. Now at this point, I am going to take my c squared with this is a constant and pull that out here. So I have 2 pi equals the integral. Well, c squared times pi is on the outside. The integral from 0 to 2. And I have x squared times 4 minus x squared dx. Right? I don't have to do u sub. I'm just going to distribute that x squared and just integrate. Okay? This is going to become 4x squared. This is going to become minus x to the 4th dx. Okay? And now I can integrate these. I add 1 to the exponent and divide by that exponent. Okay? Minus. I add 1 to the exponent and divide by that exponent. Okay, I can put a 1 here if I want. I don't have to. I want this from 2 to 0. And I am still multiplying this whole thing by c squared pi equals 2 pi. Well, I tell you what. Let's just get the pi right out of there. If I want to, I can divide, because I'm multiplying, on the right side, I'm multiplying c squared times pi times this thing right here. So if I divided both sides by pi, now it's a little bit easier. Okay, that pi freaks people out, but it's just one simple move to get it out. All right, I love zeros, because when I put zeros in, everything goes bye-bye. So let's start by putting our 2 in. Okay, 4 times 2 cubed over 3 minus 1 times 2 to the 5th over 5. Okay, minus putting in zeros, they go bye-bye. Okay. Times c squared equals 2. All right, well, let's do what we got here. This is going to be 2 cubed is 8. 8 times 4 is 32 over 3 minus 2 to the power of 5 is actually 32 as well over 5 times c squared equals 2. Let's continue our work over here. Now let's go purple. All right, so now I've got 2 equals c squared times. I'm going to multiply both of these by 5 and both of these by 3. So I'm going to have, oh my God, is that 160? 160 over 3 minus, 96? Oh, over 15. Minus 96 over 15. All right, and now if I do my math right, keep in mind, we don't get a calculator. Try not to go fast and mess this up. All right, 160 minus 96 should give us, this is a lot of writing. The bottom will still be 15, okay? 64. Yeah, 60, yep, 64. Now, I've got to get C alone. So I've got to start doing opposite math. All right, hang with me. I know this is a, so I'm going to multiply this by the reciprocal. 15 over 64. C squared equals, multiply this times 15 over 64. 2 can go into here 32 times. So I got 15 over 32. And I am going to take the square root of both sides. And I'm going to get positive and negative square root of 15 over 32 equals C. But wait. What does it tell us about C? Looking in the top right here, C is a positive constant. Positive constant. So when I go back down here, we don't need the negative one because of the problem. We only need the positive. That's our answer. And considering there were only 3 parts instead of 4 parts, that was a lot of work. It was almost a half an hour. with the explanations and excessive work and figuring things out before the algebra, we really took our time and averaged about 10 minutes for each one of these. Okay? Not bad. Thanks for hanging in there. You're probably mentally exhausted, unless you did these right and you just checked your work, and in which case, hey, kid, you knocked it out of the park. I'll see you for problem 4. Bye-bye.
Don't forget to subscribe and ring that bell.